the second part of 1.2. So we are looking at different types of symmetry that we can see both graphically and algebraically. So graphically, I can tell when things are symmetric with respect to the y-axis when it looks like a mirror image over that y-axis. So it's the exact same on the right and left. If it's symmetric with respect to the origin, it's like it got rotated 180 degrees around the origin. And being symmetric with respect to the x-axis will be like a mirror image around the x-axis. So here's my x-axis. It's the same on both sides, total mirror image. So you can visually tell on the graph, but we can also algebraically tell when we are symmetric with respect to the y-axis. That is when the x is replaced with a negative x. If it is symmetric with respect to the origin, then algebraically what I can tell is that we are replacing x with negative x and y with negative y. And to tell if I am symmetric with respect to the x-axis, algebraically, it looks like replacing the y with a negative y. So let's see what that even means. I'm going to check out number 1 here to see if I'm symmetric with respect to the x-axis or not. So that would be replacing a y with a negative y. So I'm going to put a negative y equals 2 times x cubed and see, is that saying the same thing? And honestly, no, those are not saying the same thing. So this is not symmetric with respect to the x-axis. Now let's check and see with respect to the y-axis. If it is symmetric with respect to the y-axis, that would be replacing the x with a negative x. Should give us the same thing. A negative x cubed is going to give us like a negative in front, so a negative 2x cubed. And again, this does not equal the same thing. Those would not be the same graphs. So for that reason, it is not symmetric with respect to the y-axis. All right, and then to check and see if it's symmetric with respect to the origin, we are going to replace the x with a negative x and the y with a negative y. We're going to do both. So algebraically, this again gives me a negative 2 times x cubed. And if I divide by negative 1 on both sides, I am now down to y equals 2x cubed, which this is what we started with. So for that reason, this is symmetric with respect to the origin. Okay, so that's how I can algebraically tell. You're also welcome to put this in your graphing calculator and see if it looks like, as far as the origin goes, it would look like it was rotated 180 degrees around the origin. Okay, so next up, we're looking at graphing this x minus y squared equals 1. So if I'm thinking about symmetry, so I think we're most used to graphing something that says y equals, so I'm going to do a little algebra here first. So I will subtract my x on both sides, divide by negative 1 on both sides, and now I will take the square root on both sides. Because I'm taking the square root, I should put a plus or minus there, but I'm going to use symmetry, like it says here, to graph this. And by that I mean, because there's a plus or minus, I'm just going to look at the positive side here first, and then I'll deal with the negative. It should be symmetric. And I'll show you what I'm talking about. So I'm going to do an XY chart for like a positive square root of x minus 1. Probably not going to put any negatives in there. I'll start with a 1. And since I kind of want this to turn out nice and pretty, I'll probably substitute a 5 in because I know that 5 minus 1 is 4, and I actually know the square root of 4. So I'm going to plug in some numbers that make this a little easier for me. I'll do like 10. I know that 10 minus 1 is 9, and I can actually take the square root of 9. Nice, pretty numbers. So when I substitute my 1 in, I get the square root of 1 minus 1, which is the square root of 0, so 0. I get the point 1, 0. When I substitute the 5 in, I get the square root of 5 minus 1, so the square root of 4, which is 2, 0.52. 10, when I substitute 10 in, I get the square root of 10 minus 1, so the square root of 9, which is 3. So this is kind of off the chart here, but I'm kind of getting that basic shape. And that was the positive square root of x minus 1. If I'm going to deal with this negative right here, a negative square root of x minus 1, it should be symmetric with respect to the x-axis here. So instead of being 2 up, I should go 2 down and hit this point right here. So I'm going to connect the dots. There we go. It's like a sideways parabola. And to check our answer, you guys can use a graphing calculator. You can go onto Desmos or GeoGebra, graph this, and see what it says. Because of the way this is set up, it doesn't say y equals, so I'm going to probably use something online. The graphing calculator requires that we have y equals when we graph it. So I'm going to go on to GeoGebra, and here is my graph of the x minus y squared equals 1. And that does look like what we drew, so we can tell that we got it correct. I would probably check those points 1, 0, and 5, 2, 5, -2, and yeah, it hits those same points. All right, and our last topic here has to do with this circle. It says standard form of the equation of a circle is that a point xy lies on the circle of radius r and the center hk if and only if this equation is true. Lots of letters. Let's see what they're talking about here. HK is the center, which for us, the point -1, 2 is the center, which means that the h is -1 and the k is 2. We also see this other point on the circle. This is the point 3, 4, which that point is not really in this equation. I need to find the radius in this equation. So we're going to reach back to our last lesson. And I'll put this in blue here. We learned last time how to find the distance between 2 points. So when I find the distance between these 2 points, I'm finding the radius, which the radius is in this equation. So just a reminder, that distance formula is right here. So I'll call this my first points, like x1, y1, and my second point has x2 and y2. So in this distance equation, I get the square root of -1 minus 3 all squared plus 2 minus 4, again, all squared. So I'm going to do my order of operations here. I end up with a -4 squared plus a -2 squared. So square root of 16 plus 4, which is the square root of 20. Not a very pretty number. I can simplify this. I do know that 20 is the same thing as 4 times 5, and I actually know the square root of 4. The square root of 4 is 2. I'm not sure what the square root of 5 is, though, so I will leave square root of 5 alone. This is the most simplified version of the square root of 20. And I know I had a d for the distance, but that is what was giving us this r, the radius. So I'm going to call it r. That means I have the h and the k, and then I just barely found the r. So I have these 3 pieces of information that I need in my equation. The x and the y are going to stay x and y. So I get x minus my h is -1. Instead of minus -1, I'm going to put x plus 1, all squared, plus y minus the k we said was 2, all squared, equals the r squared. The r we said is 2 root 5, and it has to also be squared. So to simplify this down a little bit, my 2 root 5, or in other words, root 20, same thing. If it is squared, my square root squared get rid of each other. They're inverses. So now this all equals just 20. Okay, so this is the standard form of our circle. All right, I hope that helps. Let me know if you guys have any questions.